Hello students, we'll do a quick review to the MCQ section of the organic review task which you guys did 2 to 3 weeks ago. For the structured question, we have already reviewed them in class, so I don't think I need to record another video for that purpose. Those of you who submitted it on time, you have received an email telling you your scores. Yep, so I presume that you have the questions with you, so we'll do a quick review right now. For question 1, you were told that industrially, ethyl ethanoate may be prepared from cheap, low-grade ethanol as follows. Many of you thought that the first step is a reduction, but did you realize that the first step removes H2? So in fact, it is an oxidation reaction. Okay, so the first step is an oxidation reaction, so do not mistook that is a reduction. Okay, the second step uses copper as the catalyst, and then ethanol is being added. All right, so the aldehyde over here, right, has a carbonyl carbon group. So you notice that after the reaction, the carbonyl oxygen become an OH. Okay, and then one of the H is missing from the O. So this resembles some form of nucleophilic addition. And then in the final step, again, H2 is being removed. So it's an oxidation reaction. Okay, so question asks, which process is included in the above sequence? Okay, so for option A, it's written as disproportionation. Yeah, so you notice that throughout the whole reaction, whole series of reaction given to you here, there isn't an atom or there isn't an element which is being reduced and oxidized at the same time. Yeah, so if you wish to, you can quickly calculate the oxidation states, but you do not have to. Yeah, so for option A is incorrect. For option B, electrophilic addition, again, there isn't any electrophilic addition. The two processes taking place are oxidation and nucleophilic addition. Okay, so nucleophilic addition will be our choice. Reduction is the common wrong answer. Yeah, because there's no reduction. In fact, it is the reverse of reduction, which is oxidation. For question 2, question is which process will not give a good yield of this particular product? Okay, so if you need visual guides, you can actually draw it out. So it looks something like that. It has a methyl ketone group, and then a CH2, 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 and then followed by a carboxylic acid group. Okay, if you do a quick numbering in the carbon, that will be 1, 2, 3, 4, 5, and 6. Okay, then if you look at all the options, especially option D, look deceivingly straightforward. Yeah, option D is actually oxidative cleavage. Okay, so if you wish to, you can straight look at option D, because you will be able to find the relevant numbered carbon over in the starting material of option D. So I'm going to number it 1, 2, 3, 4, 5, 6. Okay, this make it very straightforward, because if I perform oxidative cleavage, this particular portion will give me CO2, and then the remaining portion will be able to give us a good yield of the products. Okay, so option D is the one which is likely to give a good yield, so I will not be choosing option D. Yeah, so let us go back to option A. So again, I'm going to do a numbering. So 1, 2, 3, 4, 5, 6. So we can see the skeletal structure, sort of visualize the skeletal structure out there. Yep, so the first step is an elimination step. So for elimination steps, I'm going to produce a highly substituted alkene. Yeah, so it is a competition between a tri-substituted alkene here, okay, and a di-substituted alkene here. Yeah, of course, the tri-substituted alkene is likely to dominate, and then after it's being formed, I can then perform oxidative cleavage over here, and then it is likely that I will be able to get a respectable yield of the product. Yeah, so I think option A is also okay, right? So if you look at option D, you have an amide over here. Yeah, so again, I'm going to do a quick count to the number of to the carbon here. So that will be 1, 2, 3, 4, 5, and then 6. Yeah, so KOH aqueous performs 2 roles over here. The first role it performs is in the hydrolysis of the amides to give us the carboxylate anion. The next step, the next purpose is to perform a nucleophilic substitution to replace Cl for OH. Yeah, so in the process, I will draw out the products, the intermediate products. It will be a carboxylate anion, so that will be carbon number 6 followed by 5, 4, 3, 2, 1. So 5, 4, 3, 2, 1, and then carbon number 2, the Cl is likely to be replaced by a OH. Okay, and then in the presence of a strong oxidizing agent, I'm going to the secondary alcohol at carbon number 2 is going to be oxidized to a ketone, and then in the acidic condition, the carboxylate is likely to be protonated. Yeah, so in that case, option B seems to be okay as well. Yeah, so since A, B, D are fine, therefore C will be the answer because C is not likely to give a good yield. Okay, are we able to double check that? Yes, we can do that, because if you take a look at the condition for part C, it's given to be sodium hydroxide in ethanol. So sodium hydroxide in ethanol is likely to effect elimination over here. Yeah, so if I'm going to draw the starting material to part C, right, it will look like this. Is OH, and then CH2, 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 and then CH2Cl, like this. Okay, so that's 2, 4, 6. Yep. So in the presence of sodium hydroxide in ethanol, elimination is going to take place. If I perform elimination, this is likely to be my product, okay, which is like this. So it's a terminal alkene. Yeah, so if I'm going to perform an oxidative cleavage on my terminal alkene, I'm going to get a carboxylic acid, and then at the same time I'm going to get ketones. But if you do a quick carbon count, there is a loss in 1 carbon in the process. Yeah, so because there's a loss in 1 carbon, it is not likely for me, or rather the loss of 1 carbon will mean that the product is not the same as the one I'm looking for. Okay, so therefore the answer I'm going to pick will be C for question 2. Alright, next we'll move on to question 3. Which of the following reactions would not produce 1,3-dicarboxylic acid? Okay, now Fehling's solution followed by acidification, right? We all are aware that the compound given to us in this case is an aromatic aldehyde. Okay, so this question is to test whether the students recognize that aromatic aldehyde cannot be oxidized by Fehling's but can be oxidized by Toland's reagents. Yeah, so because of that, I will straight away pick option A as my answer. Yeah, because for the rest of the option, I will be able to get 1,3-dicarboxylic acid. Let us run through. Okay, so for acidified KMnO4, oxidative cleavage over here. Yeah, and in the strong oxidizing condition as well, because it's acidic, likely to be hydrolysis as well. Hydrolysis is likely to kind of take place, although normally we do not test a question like that. Yeah, but we are going to choose the best answer of all the options anyway, so therefore B is likely to give us 1,3-dicarboxylic acid. Okay, for C, in the presence of sulfuric acid, Cn will undergo hydrolysis to give us carboxylic acid, and then at the same time the ester will undergo hydrolysis as well. Okay, in the presence of aqueous alkaline iodine followed by acidification, the methyl alcohol group will undergo oxidation and give us a carboxylate anion. The acidification will result in the production of carboxylic acid from the carboxylate. Same story goes for the methyl ketone group. Okay, so therefore given all the options A, B, C, D, B, C, and D, they are likely to produce 1,3-dicarboxylic acid, so A is the odd one out, so A is incorrect. Okay, so we'll pick A as the answer because it will not produce 1,3-dicarboxylic acid. Next, we'll look at question 4. We have benzoyl glycine was first isolated from Stellen's urine Okay, so we have an amide over here and a carboxylic acid. Which properties does this compound possess? Okay, if you are not very sure how to look at the structure, we can draw out the structure in skeletal formats. Okay, so we have an amide, okay, and an NH, and a CH2 and a carboxylic acid like this. Okay, yeah. So question is, which properties does this compound possess? It can be hydrolyzed to produce an amino acid. Is this right? So we'll try to see if this is correct. So if we perform hydrolysis, the amide will be hydrolyzed, and then in the process we are going to produce something like this. This resembles glycine. Okay, so remember, glycine is the only amino acid that does not have a chiral center because the R group is a H. Okay, so option 1 seems to be correct. Option 2, it can be made by reacting benzoyl chloride with amino ethanoic acid. So what exactly is amino ethanoic acid? So this is ethanoic acid. Amino ethanoic acid means that this particular carbon contains the nitrogen group or the amino group, NH2 group, and then if I react with benzoyl chlorides, it's going to give me this compound. So yes, I can pick option 2 as the right option. Option 3, it can be neutralized by reaction with co-aqueous sodium hydroxide. Question is, it can be neutralized, okay, by reaction. So aqueous sodium hydroxide will not allow benzoyl glycine to undergo hydrolysis because under cold condition, the activation energy is not likely to be overcome. Yeah, so therefore, acid-base neutralization reaction can take place with the carboxylic acid group. Okay, so option 3 is also correct. Yeah, so therefore for question 4, I'm going to pick option A. Okay, because all the 3 options are right. Next, we are going to look at question 5. When heated strongly, phthalic acid undergoes condensation reaction to form phthalic anhydrides. Okay, so this particular reaction is some sort of a condensation reaction because water molecule is being eliminated along the way, so you can view this as some form of addition elimination reaction as well. On reaction with water, the anhydride gives phthalic acids. What would be formed when phthalic anhydride reacts with ethanol instead of water? This question is quite common because normally the incorrect answer chosen by students will be D. Okay, in most cases, students will think that D is the answer. Okay, but D is not the answer. You will not be able to get a diester. The reason is quite straightforward because let us try to imagine how phthalic anhydride will react with ethanol. Okay, yeah. So when it reacts with ethanol, right, it is likely that the ring will open up first, and then I'm going to get one of the carboxylic carbon end as the ester. Okay, I'm going to draw the ester out. Then what about the other end? The other end, right, will become the carboxylic acid. Yeah, because if you look at your ethanol, right, it can be splitted in this way. So I'm going to highlight for you to take a look. Yeah, so I can just highlight the ethoxy group. So this is the ethoxy group. Okay, and then for the H, it will be here. Okay, so my intermediate products must be the carboxylic acid and the ester together. Then another question I'm going to ask everyone is, will ethanol be able to react with carboxylic acid without the presence of corn sulfuric acid as the catalyst? Yeah, so the answer is no, right? So if the answer is no, then I'm not going to choose option D because option D is an impossible product without the presence of strong concentrated sulfuric acids. Yeah, so therefore the best option will be C. The remaining 2 options are definitely nonsense because if you look at over here, right, it's an oxygen instead of a carbonyl carbon group. Yeah, so therefore A and B can never be the answer. So most of the time it's a struggle between options C and D. Okay, yep. Then next we are going to look at question 6. Okay, so for question 6, we have experiments. Okay, experiments are carried out on three compounds, Q, R, and S. Okay, and then we have to take note of what are these compounds. Yeah, so for Q, it contains 3 esters group. For R, it contains a cyanyl group, and for S, 2 bromo group. Okay, so question is, a sample of 0.01 mole of each compound is heated under reflux with 50 cubic centimeters of 1 mole per dm cube of sodium hydroxide. You were told that this is in excess. Yeah, so essentially we are looking at a complete alkaline hydrolysis. Okay, so since we are looking at complete alkaline hydrolysis, we can easily draw the corresponding products. Yeah, so for Q, I'm actually looking at a triol. Okay, so I'm going to be drawing a triol over here. So this is a CHOH and then a CH2OH. And then for R, I'm going to end up with a carboxylate salts because this is an alkaline hydrolysis. Okay, and then for S, I'm going to end up with a diol. Okay, and then the question is, any ammonia gas produced was expelled from the solution. So the ammonia gas produced is from R. Yeah, because the C triple bond N, the N group will be lost as ammonia in alkaline hydrolysis. And then we were told that the excess sodium hydroxide was then titrated in each case, okay, and found to require 20 cubic centimeters, 30 cubic centimeters, and 40 cubic centimeters of 1 mole per dm cube of hydrochloric acid for complete neutralization. So which sequence of compounds matches these results? Okay, so the first thing we need to look at is number one is we have 50 cubic centimeters of 1 mole per dm cube of sodium hydroxide, and that's equivalent to 0.05 moles of sodium hydroxide. Okay, and if you take a look at Q, there are 3 ester bonds to be hydrolyzed, so I will need 0.03 moles of sodium hydroxide. For R, I have 1 equivalent of Cn to be hydrolyzed, so I will need 0.01 moles of sodium hydroxide. For S, there are 2 Br to be replaced, so it's clear that I will need 0.02 moles of sodium hydroxide. So I'll just write them down over here: 0.03, 0.01, and 0.02. Yep, and because I started off with 0.05 moles of sodium hydroxide, that means that upon hydrolysis, I am left with 0.02. For R, I'm left with 0.04. For S, I'm left with 0.03. Yep, and with that, given 1 molar HCl for complete neutralization, so therefore for Q, I will need 20 cubic centimeters, so I will choose options A or B. For R, I will need 40 cubic centimeters, and that only agrees with option B. And for S, 30 cubic centimeters, so that only agrees with option B. So for question 6, I will choose option B as the option. Alright, next, for question 7, why are amides less basic than amines? Basically, this question has a very straightforward answer from your lecture notes. The lone pairs of electrons on nitrogen delocalized over the CO pi system into the carbonyl oxygen. But we will need to read through all the options to see which one makes perfect sense, okay, or the closest in meaning to what we have just discussed. So for option A, amides forms with the ion. This is nonsense because it's not possible because itself is neutral. Option B, amides have resonance structures involving the movement of a pair of electrons from the nitrogen to oxygen. This is not the best description. Yeah, but within all the options, we'll have to check again. But so far, B seems to be okay. I mean, you have that resonance structures being drawn from your lecture notes. Okay, for option C, electrons on the nitrogen atom move on the Cn, giving it double bond character, so that it's difficult to break. This is nonsense as well. Basically, the delocalization of the lone pairs of electrons over the CO pi system give the CN bond a partial double bond character. Yeah, but this has nothing got to do with whether the bond breaks or not, because whether the amide is basic or not has nothing got to do with the ease of breaking the CN bond. For option D, the amide carbonyl group withdraw electrons from the NH2 to make the hydrogen atom more acidic. This is sort of a true statement. Yeah, so if you take slightly more advanced chemistry, especially those of you doing H3, you will know that if we use a non-nucleophilic base, it is possible to deprotonate an amide, and our amide can act as a nucleophile after deprotonation. However, option D does not explain the question why are amides less basic. Yeah, so with that, there's only one option to choose. That is option B for question 7. Okay, next we look at question 8. The reaction of phenylhydrazine is similar to that of 2,4-dinitrophenylhydrazine. Okay, so the main group here, of course, we are looking at the hydrazine functional groups. Question is which changes in bonding occurs in the reactant and products during the course of the reaction. Okay, so I think it does help if I can draw out the phenylhydrazone products. Okay, so there will be a C and a H here and a double bond N. Okay, and an NH followed by a phenyl ring. Okay, and then the oxygen and 2 of the hydrogen gives us the OH bond in the condensed product, which is water, or the elimination of the small molecule. Okay, so with that, let us try to indicate which are the new bonds being formed. So we have CN over here and the OH. So we have CN and OH. There's no CC bond being formed. And when CN is being formed, of course, CO is being broken, as well as the two of the NH bond. So NH bond is broken. So with that, we are only left with one option, which is option C. So options 2 and 3 are correct. Okay, next, we'll look at question 9. Dopamine is a neurotransmitter found in many animals, including vertebrates and invertebrates. Which of the following statements are correct? Okay, so we have to be a bit careful. If I look through all the options, we have those involving acyl chlorides, we have those involving bromine, water. We also have those involving carbonates. So we have to be a little careful with our selection. Okay, so option 1, 1 mole of dopamine reacts with 3 moles of acyl chlorides. Can we identify the 3 groups which react? So we know that phenolic OH forms ester, as well as amines form amide. Carboxylic acid, remember, does not react with acyl chlorides. Okay, so therefore option 1 is correct. Next, we look at option 2. 1 mole of dopamine reacts with 1.5 moles of aqueous bromine. Okay, so in our case here, we have 2 OH. So it is likely that it will undergo electrophilic substitution and get all the Br in. Yeah, but so it seems that it is correct, 1.3 moles of bromine, but not to forget, in the course of the reaction, the byproduct being produced is 3 HBr. Yeah, so therefore dopamine will react with 3 equivalent of bromine to give 3 substituted Br on the phenyl ring of dopamine, as well as 3 HBr as a byproduct. So therefore option 2 is incorrect. Okay, option 3, 1 mole of dopamine reacts with 3 moles of sodium carbonate. This is incorrect because sodium carbonate will only react with carboxylic acid. Okay, so this is incorrect. So therefore, looking through all the option, only D is correct. Okay, finally, we have question 10. Okay, compound V with molecular formula C6H12, we can easily perform a degree of unsaturation calculation to be 1, was reacted with acidified potassium permanganate, and the resultant mixture obtained was colorless. The mixture was therefore distilled to form distillate W and residue X. Okay, so there are 2 components. Distillate W is able to form a yellow PPT with aqueous alkaline iodine, so therefore it contains the methyl ketone group, okay, CH3CO. Okay, residual X reacts with sodium carbonate to give a colorless gas, so residual solution X is likely to be a carboxylic acid. Okay, so with that, let us look through all the options. Compound V will decolorize aqueous bromine. This is definitely correct, because compound V with 1 degree of unsaturation, upon reacting with potassium permanganate, undergoes oxidative cleavage. So the 1 degree of unsaturation is likely due to a CC double bond. So option 1 is correct. Option 2, distillate W can form an orange PPT with 2,4-dinitrophenylhydrazine. This is correct as well, because it is likely to be a ketone, definitely not an aldehyde. Okay, and definitely not carboxylic acid, etc., because carboxylic acid will not be able to give a yellow PPT with 2,4 with aqueous alkaline iodine. So definitely distillate W can form orange PPT with 2,4-DMP. Option 3, residual solution X can form white fumes with PCl5. This is correct as well. Why is that the case? Because X is likely to be a carboxylic acid, and carboxylic acid contains the hydroxyl group, which will react very readily with the electron deficient phosphorus center of PCl5. So in the process, it will be replaced with Cl to give you the acyl chloride. So option 3 is also correct. So 1, 2, 3 correct. So I will pick option A as the answer to question 10. Okay, so I hope you find this review beneficial for your preparation for your upcoming consolidation test too.